Okay, so this is the exciting part. We're going to conduct the hypothesis test. Now, as we're reading the problem, I propose that we keep track of the given information. I'm going to be keeping track of that here on the right-hand side of our screen. The National Institute of Mental Health published an article saying that in any 1 year period, approximately 9.5% of American adults suffer from depression or a depressive illness. So notice, this is a claim being made about the whole population, about all American adults. So here, I'm already thinking that they're claiming P to be equal to 0.095. Remember, when we say P, we need to state this value as a proportion, okay, not as a percentage. Here we have 9.5%. If we go ahead and divide this by 100, we get 0.095, which is the proportion equivalent to 9.5%. Let's continue reading the problem. Suppose that in a survey of 1,000 randomly selected people in a certain city, 70 of them suffer from depression or a depressive illness. Here we have the sample size being 1,000, so N is equal to 1,000. And then the number of successes is 70, so X is equal to 70. This is the number of people that said, yes, I suffer from a depression or a depressive illness. Now, we're going to be conducting a hypothesis test at a 0.05 level of significance. This is our alpha level. Okay? We're conducting this hypothesis test to determine if the true population of people in the city suffering from depression or a depressive illness is lower than the proportion in the general adult American population. This last part here is going to help us write our alternative hypothesis. We're going to conduct this hypothesis test to determine if the true population proportion of people in the city suffering from depression or a depressive illness is lower than the proportion in the general adult American population. This last part is going to help us identify the alternative hypothesis. Starting with step 1, we're going to write the null hypothesis. Here we're saying P, the true population proportion of this city, is the same as the true population proportion of the American adults. We're going to write P is equal to 0.095. Here we're saying, let's just assume that the true population of people in this city who suffer from depression or a depressive illness, let's just say that this is the same as the proportion that we found from looking at all American adults. Now, the alternative hypothesis would be that P is less than that value. We know that we're doing a left tail test because it says carry out this hypothesis test to determine if the true population proportion of people in the city who suffer from depression or a depressive illness is lower than the proportion that was found from looking at all American adults. I forgot to write down the given information here on the right, so let me go ahead and do that. Here, instead of writing P, I'm going to write P naught because this is the value that we're claiming P to be, 0.095. Let me go ahead and do the same here above. This is the value that we have on the null hypothesis, which is why we have P naught. I want to make sure to write P naught because this is the value that we're claiming P to be. Okay? But it could be the case that P is some other value. That's why I don't want to write P is equal to this value. So that is our P naught. We said N is equal to 1,000, X is equal to 70, and alpha is equal to 0.05. And you can also write alpha here on step 1. Now here we could write other values that we're going to need. For example, we know that we're going to need the value of Q naught. The value of Q naught is 1 minus P naught, which is equal to 1 minus 0.095, which is equal to 0.905. I mean, this value is not given to us, but if we have P naught, we can find Q naught. Let's go ahead and move on to step 2. In step 2, we're claiming that P hat follows a normal distribution and that the center of the distribution is P naught and that the standard deviation of the distribution is the square root of P naught times Q naught divided by N. In step 2, we're claiming that P hat follows a normal distribution. In this step, we're also going to indicate what the value of the mean and the standard deviation of the distribution are. Okay? So let me replace the value of the mean. P naught, we have a value for that, 0.095. Now, the standard deviation is going to be the square root of P naught. Let's, again, replace that value with 0.095 times Q naught. We found Q naught here. We have Q naught being equal to 0.905. And let's also replace the value of N. N here is 1,000. Now here's the recommendation that I'm going to make. I recommend for you to type this value into your calculator. The square root of 0.095 times 0.905 divided by 1,000. Make sure that the quotient here is inside the square root. Okay? Go ahead and type that into your calculator. You should be getting 0.0092722,705. Okay? Notice here, I'm writing all the values that I get after the decimal when I enter this on a calculator. I personally would keep it as the square root of 0.095 times 0.905 divided by 1,000. But I've seen that some students get overwhelmed with those type of expressions. So here I'm saying, just type it on your calculator, get a value, make sure to write the whole value that you're getting on your calculator. Okay? I think this is going to make it easier to move on to the next steps. So again, here we have the p-hat distribution that follows a normal distribution. The center of the distribution, the mean of the distribution, is 0.095. And here's the standard deviation of the distribution, which is the value that we got from taking the square root of p naught times q naught divided by n. Now, step 3 is going to be finding p-hat. P-hat is going to be equal to x divided by n, that is 70 divided by 1,000, which is 0.07. Now, we're ready to move on to step 4. Here, I'm going to show you how to find the p-value using a calculator, and I'm also going to show you how to find the p-value using Google Sheets. Again, for this step, I recommend that you take the time to visualize the normal distribution and the area that you're trying to find. We're visualizing this normal distribution. Here, we're going to assume that the center of the distribution is P naught, which is equal to 0.095. Then we're going to label the p-hat value. P-hat is on the left-hand side of P naught. Let's just say it's somewhere around here. Go ahead and label it. Here, we know that we're conducting a left tail test. We need to find the area below p-hat equal to 0.07. We're working with a normal distribution. If we're doing this on a calculator, we're going to use normal CDF. The lower bound is going to be a large negative value, that is negative 1E99. The upper bound is going to be our p-hat value, 0.07. The mean of the distribution is 0.095. And the standard deviation of the distribution is going to be the value that we got earlier for the square root of p naught times q naught divided by n. So I'm just going to copy and paste that value. If you enter this function on your calculator, you're going to find the area below p-hat equal to 0.07, and that is going to be the p-value. If you're using Google Sheets or Excel, you're going to click on the empty cell. You're going to type in equal norm.dist. Okay. This function is always going to give you the area to the left of the p-hat value you provide. So if you provide the p-value equal to 0.07, it's going to give you the area below this p-hat value, which is the area that we're wanting to find. Here's our p-value, our mean, and the standard deviation. Again, I'm going to copy the value that we got earlier for the standard deviation. At the end, you need to type in true. Let's go ahead and find the p-value using a calculator. We're going to click on second bars to get the list of the distributions. We're going to go down to normal CDF. Our lower bound is negative 1E99. Our upper bound is 0.07. The mean of our distribution is 0.095. And here we need to enter the standard deviation. Go ahead and enter the whole value. Again, you don't want to round here. Go down and press enter. Again, press enter. And here you have it. This is your p-value. Now you can also do this on Google Sheets or Excel. On an empty cell, you would type in equal norm.dist, open a parenthesis, enter the p-value, the mean, and the standard deviation. Then go ahead and type in true, close the parentheses, press enter, and there you have it. This is going to be your p-value. Now keep in mind that Excel, Google Sheets, and the calculator is doing their best at approximating the area under the curve. And so we are going to get a different approximation. You're going to notice that the last few values of the p-value are different. Now, because those values are far away from the decimal point, they're not going to make a difference. So it doesn't matter if you use the value that you found here on Google Sheets or if you use the value that you found on the calculator. Coming back to our notes, we're going to write the value of the p-value. Always write the p-value is equal to the value you got. Never write p equal to something because then you're going to get confused. You're going to think that this value is the population proportion, right? Because we use p to denote the population proportion. So always write the p-value is equal to whatever value you got. I'm going to use the p-value that I got on Google Sheets. Again, it doesn't matter which one you use. I noticed that I always use the value that we get on the calculator, so that's why this time I'm deciding to use the value that we're getting on Google Sheets. Now that we have the p-value, we're ready to make a decision. Here we need to compare the p-value and the alpha value. We have alpha equal to 0.05. Is your p-value less than alpha, or is it greater or equal to alpha? Notice the p-value is less than alpha, which means that we're going to reject the null hypothesis. Let's go ahead and think about what we're seeing. Notice this probability here, the area below p hat, is really small. Here we're saying we conducted a study with 1,000 people. This is a big sample size. Okay? We randomly selected this 1,000 people, and we got p hat equal to 0.07. The p-value is telling me that it's really unusual to see such a p hat or a value less than that. The probability of this is 0.35%, really low. If I have a big sample and I randomly selected these people and I'm getting something that I'm not supposed to get, right? Something really unusual, something that has a really small probability, then I have a reason to believe that the center of this distribution is not 0.095, which is why I'm rejecting the null hypothesis. On step 5, we're going to write a conclusion. We're going to say there is sufficient evidence to conclude the alternative hypothesis, right? What is the alternative hypothesis? The alternative hypothesis is that the true population proportion of people in the city suffering from depression or a depressive illness is lower. So I'm just going to go ahead and copy this. Is lower than 0.095. Notice here we're describing the population proportion and we're saying this value is lower than 0.095. In other words, we have sufficient evidence to conclude that p is less than 0.095. Notice here, I'm describing that we found sufficient evidence to conclude the alternative hypothesis, and I'm also taking the time to describe the null hypothesis using the context of the situation. Now that I think about it, we should be adding the significance level here. At a significance level of 0.05, there is sufficient evidence to conclude the alternative hypothesis. Actually, let's make sure that every time we write a conclusion, we state the significance level. We're stating the significance level. We're stating whether there's sufficient evidence or not sufficient evidence to conclude the alternative hypothesis. And we're making sure to write a sentence that describes the alternative hypothesis. Now, it took us a long time to get through this hypothesis test. And the reason why is because we were going into details about how we're conducting each step of the hypothesis test. We're going to look at one more example, but this time we're going to pick up the rhythm. We're going to go a little bit faster.